A man receives a platinum ring from his fiancée. Before the wedding, he noticed that the ring feels a little light for its size, so he decides to determine its density. So notice that rings would be made of things like gold or platinum, right? So they're pretty dense. What if it was made of aluminum? It would feel pretty light, okay? He places the ring on a balance and finds that its mass is 3.15 grams, right? He then finds the ring displaces 0.233 centimeters cubed of water. So what happened is he put it in a graduated cylinder. So this is like 1 cubic centimeter, and this is like 2. And you could also say milliliters, they're the same. All right. And so he noticed that. So let's say he put 1 cubic centimeter in, and then he dropped in his ring, right? He dropped in the ring, and the volume went up just a little bit. Okay. The volume went up just a little bit. So it displaced 0.233 cubic centimeters of water. So to use this method, the object's placed in water and the change in volume is measured. So here's our new volume. So you're going to subtract like 1.233 minus the 1 that you originally had in there, and you get 0.233 by displacement. All right, so he wants to know if the ring is made of platinum. Well, we have this equation. Density is equal to mass over volume. And if you forget that equation, you can remember that the units of density are grams per milliliter. So if you divide the mass by the volume, you would get grams per milliliter or grams per cubic centimeter. All right, so that's 3.15 grams. We put the mass on top, and the volume is 0.233 centimeters. So we put the volume on the bottom, and you get 13.5 grams per cubic centimeter. Okay, so 13.5 grams per cubic centimeter. The question is does this correspond to platinum? 13.5. Okay, so platinum is 21.4. So what do you think? Could it be mercury? Kind of matches, right? So yes or no? Could it be mercury? What do you think? You know anything about mercury? Can't be mercury. Mercury's a liquid. So has probably some kind of alloy, but it's not platinum, right? All right. So the density of the ring is too low to be platinum, and the ring is therefore a fake. Okay. So the woman in example 1.3 is shocked to find the ring is fake, so she returns it. And she buys a new ring that has a mass of 4.53 grams and a volume of 0.212 cubic centimeters. Is the new ring genuine? Okay, so let's go ahead and calculate that. Let's see here. All right, so that would be 4.53 grams divided by 0.212 cubic centimeters. And so that's equal to 21.3679 grams per cubic centimeter. So we can deduce from this chart that that one is close enough to platinum that we could probably assume that one is platinum and therefore correct. All right, so this is a 4 more practice problem. Okay, this is 4 more practice. 1.3. A metal cube, and this is where you got to think with chemistry. They try to make you think about things. A metal cube has an edge that is 11.4 millimeters long and a mass of 6.67 grams. Calculate the density of the metal and use table 1.4 to try to identify the metal. Okay, so let's think about that. This is a cube. Okay, so what does a cube look like? My drawing skills are somewhat lacking. I do not have a cube. I have something that's not a cube, right? But anyway, we'll assume that this is a cube, which would mean that each edge is 11.4 millimeters, all right? So each edge. All right, so 11.4 along every edge and this way also. All right, so what is how do you calculate the volume of a cube? Assuming this is a cube. So we need to calculate the density. Density is equal to mass over volume. All right, so we have the mass. The mass is equal to 6.67 grams, but we need the volume. How do we calculate the volume? What's the formula for that? So the volume of a cube is equal to the length of the cube cubed, right? So it's length times width times height, right? And the length and the width and the height, they're all the same on a cube. Of course, I didn't really draw it like that, right? So all we have to do is cube 11.4. So that's equal to 11.4 cubed, right? All right. And so, but we need that's in actually millimeters. All right, so we've kind of got a problem here. That's millimeters. So we need to actually convert that to what? Cubic centimeters. Why don't we just go ahead and do that first? So 11.4 millimeters. Okay. And let's just go ahead and convert that to centimeters. All right, so let's go back to our chart. Go back. How many centimeters is a millimeter? All right, so here we've got centi and milli, okay? So a centimeter is 0.01 meters, and a millimeter is 0.001 meters, right? So 10 to minus 2, 10 to minus 3. So how many millimeters are in a centimeter? So it's 10. So we've got 10 millimeters are in 1 centimeter, all right? So is our number, our millimeter number, going to be bigger or smaller? So if we've got 11.4 millimeters, what are we going to have to do to get centimeters? We're going to move our decimal place. So if we divide by 10, which way does the decimal place go? So that's going to be 1.14 centimeters, right? So the density is equal to 6.67 grams divided by 1.14 centimeters, but we need to cube that in order to get the volume. So we cube 1.14 and we cube the centimeters, right? So if we convert, let me go back and do it the other way. I'm going to back up and put that number in later, okay? So 1.14 centimeters cubed is equal to 1.48 cubic centimeters. Okay, so now we can put the 1.48 centimeters cubed here, and that gives us 4.5020 grams per cubic centimeter. So 4.5. And if we go over here and look, what would our metal be? Probably titanium. And I hope I didn't confuse you too much because I'm not so sure that I could explain that in a very straightforward way. I think that I did that a little backwards. We're going to be working some more problems with density. Just keep in mind, what did we do here? We found the volume of the cube. Okay, and here's our volume. We divided the mass by the volume to get the density. Okay.